he started tonight with talking about Pulumi and Terraform and some of that stuff, and I am going to kind of run with what the topic that he was talking about. I've dubbed my talk Systemic Deployments, which is really talking about the complexities of deploying and managing distributed systems over the lifetime of the distributed system. Or I really should say the systemic environment in which it is a part of. Because a lot of the tools out there do, well, let's talk about what distributed systems are first. Now I'm out of sync. There we go. Okay, we had a whole bunch of different types of distributed systems these days. Some of the very notable ones are like Kubernetes. That's container management, basically. You know, I'm paraphrasing a little bit. We have like Cassandra, which is a distributed database. DataStax Enterprise is built on top of that. And then we have these pretty things without words like Cosmos and DynamoDB. Cloud Spanner. Couchbase is kind of a distributed database, but also a distributed cache. Then we have streaming with Kafka. We have, I mean, this is just a few, right? I mean, you go to any Wikipedia page where you type in distributed something, distributed streaming, distributed object store, distributed database, and you're going to get like 100 open source projects or some crazy number, right? There's a lot of stuff going on. Oh yeah, and Ceph is object storage. Why do we use distributed systems? Today it seems kind of obvious. Traditionally it hasn't always been, but basically these three things. And I'm going to summarize the last 20, 30 years. The internet happened, right? I mean, everything got huge. We got way more data, way more stuff than a little single computer or maybe a few computers connected together with like a database, an app, and something else could handle. So we had to start scaling stuff out. Needless to say, distributed systems are here to stay. They are not going away. I'm pretty sure things aren't going to get simpler in that realm, except we just kind of abstract, hide, and push that stuff down, right? That's kind of like, if you go back, way back, at one point we had punch cards and then we got assembly, and assembly was easy compared to the punch cards, right? And then we got C, and that was easy versus assembly. But, you know, the jump usually isn't always evident until we get there. And right now we're kind of dealing with the distributed systems in various states. Like sometimes we're managing the whole cluster, the whole thing. And sometimes we're managing just starting it up, but something's managing some parts, but then part of it breaks and we have to figure out what in the world's going on and we don't have control over it. So then we manage it ourselves and we move back and forth between these things. In the enterprise world, the great world of enterprises, they've really just started, how should I put it? Kind of trusting the cloud in some sense. But they're starting to use a lot more distributed systems out in the cloud, and they're starting to use some things like Cosmos or DynamoDB. But most enterprises want to manage that themselves for many different reasons. So they have hybrid environments, and they'll run like DataStax Enterprise or maybe just Apache Cassandra, and then they'll run I don't know, some other distributed system on that, and then they'll have Spark and Kafka and a whole bunch of different things, right? So the enterprise has really jumped on board the whole open source bandwagon. Largely, I would say they have started pouring some money into that, so that's good. If you've been watching the Twitterverse and the realm out there, there's been a little bit of a fuss about who pays for what with open source. I think, I don't know how everybody feels, but I think the enterprise companies that are getting huge advantage out of these things should fork up a little bit more money. And or at least people to work on these things. Give more leverage to people to say, hey, I want to work on this project because we use it for this, I don't know, multi-billion-dollar thing that we do. A lot of this stuff, too, has come out of the realm of startups, where somebody sits down and is like, well, I need a system to handle all of this data. For instance, great example, Apache Cassandra. The story there is, you know, people were hanging out at Facebook, not hanging out, I guess they were working at Facebook, whatever you do at Facebook. And clearly there was a data problem, right? They couldn't shove all the images, they couldn't shove all the messages, et cetera, in like just some Oracle box and buy another bigger Oracle box every year and hope and pray that the thing was going to be big enough to do it. That vertical scale wasn't happening. So over the course of months, years, they started working on Apache Cassandra, or what eventually became Apache Cassandra, right? And now it's used by tons of companies to handle that problem. And there's a lot of other things too, like Zookeeper, you name it. Now that all these companies are doing this though, I see some companies, they just like, what would be the approach where they just seem to kind of like, oh, there's the target, run. They charge into it and then poof. I saw recently somebody said, who would deploy Kafka and not monitor, instrument, or even like have a way to introspect what is going on with Kafka? They're just hoping it does whatever it's supposed to do magically. And there's a thread that has continued with that and a lot of different resources about how to monitor this thing, how to instrument this thing, how to get observability into the Kafka cluster that they have. And I apologize if I'm saying that wrong and it's driving you crazy. I always tend to say words wrong a lot. So that's one side of things. And then there's the other side where it seems like, oh look, AWS built a thing, deployed it, and it works. I mean, of course that doesn't always happen, but you know, it tends to happen. Like they just released, do you remember what it is? Anybody remember what they just released? Well, I guess it's reinvent, right? So there's a million things. But yeah, I was thinking of Firecracker. Like that's the open source Lambda, right? And they just released that, and it's the biggest thing on GitHub all of a sudden. Like as far as immediate attention, I'm sure there's other bigger projects still. But they got 2,000 people following it already on the, what do? You favorite it, whatever you do. You click the button and you get bombarded with all the emails, right? Yeah, watch it, that's what it is. And GitHub just added a feature where you could be mailed only on versioned releases. That's only been needed for like, I don't know, as long as GitHub has existed. So anyway, you got these enterprises, you got these smaller businesses, you got some companies that seem to be able to deploy these things magically and they just work. And then other companies are like, oh, okay, we have Zookeeper and Kafka and we don't have instrumentation in this. How do we manage all this stuff? So the root of that is they start out with like installations, right? They just use a wizard or they use a CLI. And that is the root or starting point of every deployment of any type of distributed system, right? Because you need at least a node to start with to then attach other things to. And like with Apache Cassandra, you have choices in that simple starting installation, right? Binary, build, or repo, like apt-get. You go out there and you get a secure thing out of the Debian repo. Fortunately, not like NPM, where you might go get a thing and then you get your crypto stolen and then you're poor. That'd be horrible. Oh, there it goes. So like it's pretty easy to go out and get a node of, say, Cassandra running, right? Like I shot this little video, and within a minute, I've gone out and gotten a secure, good binary build of it from apt-get, started it, checked that it's there, right? Because you want to make sure everything just worked, and then I stop it. Real easy to do. But then once you get past that, everything kind of gets a little fuzzy, right? Like with Apache Cassandra, you have nodes in a cluster, right? But then in Kafka, what do you have? Do you really have nodes? Or do you have brokers, right? This verbiage is even different in the deployment of these different systems. Sorry if I just turn your sound off. I just sat on that. But as you can see, super easy, right? It didn't take much time at all. I didn't even run into a Python issue because Python's not used to do this. I have feelings about Python sometimes, especially when it doesn't work, which is regularly. And then there's other very powerful ways that give you the facade of deploying all the nodes, or say the Kafka brokers, out to do whatever the job is. And this is nice to get started with. Is it? Yeah, okay. So I'm a little hesitant because I don't know how videos work in Keynote. Like this right here is, you can, in Azure they have this thing where you can just start a test drive of DataStax Enterprise. And you can do this with tons of other stuff too, right? They have, I don't even know how many things in the marketplace. And also GCP has this, the other one, the Amazon has this, blah, blah, blah. All the cloud providers have some type of marketplace. And what this does is it deploys out an entire cluster of DataStax Enterprise with graph and analytics and all this stuff that if you took a step back, I showed that little chart there that showed what is in it, you go, whoa, this is a lot of stuff happening all at once, right? And it's handled. It's simply handled. You get out there, boom. I have a 3-node cluster. And that happened in like just a couple minutes. I cut out like a minute of waiting for it to start. But just a couple minutes, and you have a full-blown cluster with a test drive. Azure does it for like 3 hours. And I don't even know how they charge you, because like, I hope I don't get like a $1,000 bill at the end of the month. But they leave it up for 3 hours and they kill it. And it actually kills the resources. It's really neat to be able to just kind of work with it and then throw it away and then work with a new one. So that's some of the ways to start with a distributed system, right? And when you start that way, that's all great. And eventually you end up needing something like, well, you need to manage that, right? In the enterprise, you have X number of resources, or you have an IT department, let's say. And this is where things start to get super tricky. The simple stuff goes away. Now, if you can go in and click a few buttons in your enterprise and they have something magically wound together, that's great. But that usually doesn't happen. You have to go through processes, or the IT department has to give you resources and all that jazz. And that's where something like Terraform comes in super handy. But you also have to be extremely careful. If you're using Terraform to deploy, let's say you need 100 web servers, okay? And you're like, all right, I designate my resource in Terraform. And somebody was mentioning that there's a way that you can go through it. There's actually a property on resources in Terraform that's count. And the count does a for loop on that thing. Now, you need to set up data structures, like a map, that will give it its ID and other unique characteristics that it's going to need on that resource, right? So you have to have enough items in that map to step through. And then when you give it the count, it'll step through, and you give it the var dot whatever bracket, something for the index value. I forget exactly what the syntax is. But basically, it'll go through, and it's doing a for loop on it, and it'll go through that map array of all the values, and it'll put those values in. Okay? Super awesome. When all you need is just a bunch of basically rudimentary instances. So you get to your 100 web servers, and they're all stateless. That's great. You can blow them away. You can re-add some, whatever you need to do, and it's not going to affect the other ones that are out there, right? So you can take away 20, you can add 50, whatever you need to do. That's great. However, if you say you're going to create a HBase cluster, or heaven forbid, a Zookeeper cluster, okay? You go out in Terraform and you do that, every single time you run that, it will attempt to recreate the entire cluster and wire it all together again. So Terraform works on the premise of immutable infrastructure. And you can think of that in the same way that you think about like in functional programming or something like that, where you have an immutable, you set up a variable and it's immutable at that point. You use it as the value that it is, right? If you want something else, you create something else from that. And then garbage collection or whatever, depending on your language, it eventually gets rid of it. Terraform's kind of doing the same thing. It works on the premise that every time it does a deployment, it wants to change the state, the immutable state of a systemic environment to the new immutable state of the systemic environment. So if this can't be additively added to, like if it has to do an update to something, it's going to destroy the old thing and add the new thing, right, as a completely new immutable thing. And it's that state to state point which gets tricky. So then you have to go back out and say like, oh, I'm going to write some bash stuff, or I'm going to use something else to build out the cluster, et cetera, et cetera. And that's where the maintenance thing just becomes super troublesome. And I have some suggestions, some ideas about how to make that better. I don't have any like convention-based verbatim stuff like do it this way forever and it always work. This is very cloudy, oh geez, I use that word. Very cloudy space we're moving into when it comes to maintenance. So like I was just saying, if you use Terraform to dynamically create stuff with a Zookeeper cluster, it'll create that cluster and then it'll recreate it every single time. So what you have to do is you have to say, this is node Frank, this is node Sally, this is node Flower, this is node Pizza, whatever. You have to give it a unique name and create however many nodes you want to begin with. With Zookeeper, the math on that is 2n plus 1. At least that's what they tell you it is. 3 nodes is kind of, you're kind of in risky space. Zookeeper is a little fussy. Like if a node goes down, sometimes it takes a while for it to go down and it to redetermine which one is going to now manage traffic to the other node or whatever, and how to re-replicate the data between whatever the remaining nodes are. So my suggestion is use 5 or more with Zookeeper, okay? When you get 5 out there, and you give them that static name and everything, and they get their IPs and whatever, and you get them all mapped together correctly, or added, whatever you do, joined together into the Zookeeper cluster, then you're good. You're running. Terraform will know, since you've statically designated all those, it can look at the state and say, well, Frank and Sally and Flower and Pizza and whoever are still there. I don't have to destroy them because none of the things that are key, like their name or IP or unique identifier, are changing. None of those things are changing. So I can just leave those and then do whatever actual changes or additive things to the infrastructure that you've asked for, you've added to the files. I can do those now. And I'll show you some of that in just a second. But hugely important with distributed systems, when you're using something like Terraform, or even something, Ansible is kind of immutable infrastructure oriented. I'm trying to think of the other one. There's another one. Some of the, even like with Kubernetes, right? You write your YAML. You say, I want whatever stateless partitions set up that aren't going to change. I'm going to map these pods to them, right? And then I'm going to put a distributed system on that. What happens when a node goes down, though? Kubernetes and the other distributed system, whatever that is, Zookeeper or Cassandra or HBase or whatever, is going to now try to both manage the loss of that resource, right? So like if you have Cassandra, for instance, it's going to re-replicate back out to other nodes that are still available. Well, Kubernetes is going to say, well, here's a pod. And when that starts to happen real quick, all of a sudden you have this fight. Kubernetes is like, no, here's a resource, here's a resource. And Cassandra will be like, no, am I re-replicating? Do I need to rebalance the stuff? I don't know. Oh crap, now I'm rebalancing because I keep getting a node and then I'm not having the node and there's this conflict, right? They're both trying to manage that situation. There is word that one day there will be operators and there will be this wonderful magic and we'll be able to have Kubernetes intelligently manage with Cassandra or with Zookeeper or whatever, and it won't fight with the thing, right? And some operators are out there for, I think, like Confluent, one of those words. That company, they have an operator, right? It's a closed source operator, but theoretically it works, so their distributed system doesn't conflict with Kubernetes when they have it deployed out there to, whatever environment they're working with for somebody. Also with Apache Cassandra, there is ideally this 2n plus 1 math. And a lot of the time, just like that sample in Azure, yes, Azure, where it deployed those 3 nodes out there, that's great for fun. You can do a replication factor of 2, so if you lose 1 node, everything's still great. You can just keep working against it. It's not a big deal. The database just handles it. I still say 5 is better. Because if you lose 2 nodes, your system is basically going to throw errors at you and flake out when you have only 3 nodes and with the 2n plus 1. So again, I say 5 is better. Put 5 nodes out there for your cluster. Again, Kafka, the Kafkaesque nature of Kafka. 2n plus 1 brokers, I've seen the math. There's some argument. I still say bump it up. Get at least 5 out there. Stop going with the baseline of 3. I believe that so much that I made new math. So I'm sure no one's going to put that on a white paper real soon. Maybe I'll write one. Who knows? But seriously, 2 plus 2n plus 1, that gives you the perfect number of nodes or brokers or whatever they want to name the thing for the particular system. Go with that. So anyway, whew, some of the fighting and frustration of going from, oh, look, I got this easy little thing running. I have a whole cluster. I have a node. I have whatever. It's super easy to get started with a lot of this stuff, and it immediately, sometimes it'll get you into trouble. Because, like, let's say, I'll pick on, let's say, Wallstrom. There's a company, right? Wallstrom, which sells luxury items at super cheap prices. They just charge in with all this simple stuff, and they start building systems on it, or building apps, right? And microservices or whatever. They move their legacy monolith onto their microservice, web service, WX, JMX, exporter, thingamajiggy, whatever. And then they immediately start to run into problems as soon as they get load or whatever. And there's like this heavy churn of problems that come up. So that gap is not going away. But there are things that I do myself, practices. I call them all sorts of stuff, tips and tricks, patterns and practices, gotchas, whatever. And basically what it amounts to is checklists. And I focus around 2 key things that I've named this. And you have to bear with me. I use these words, and they do tend to mean very specific things to me whenever I start to create checklists. Systemic coverage, for instance, right? So anybody ever read Systemic Thinking, the books on this stuff, right? So, you make one change to, let's say, a city. Let's say we're going to, oh, it's Seattle. Let's do something real smart. Like, let's just say 3rd Street's closed. Nobody can go on it with any vehicle ever. That wouldn't have any repercussions, right? Yeah. The city would just be obliterated. Like, no one could get in and out of the city. It'd probably take 3 months to get out of the city. Everything would be just chaos. The buses would be like lost down in the ferry, and the ferry would crash into the dock. It'd be horrible. There'd be all these systemic effects of that one change, right? Well, systemic coverage is what I think of as thinking around not just I've deployed Zookeeper or Cassandra, but I've deployed this resource of resources within my systemic environment, right? So I create checklists around that. And then I've also dubbed this thing, which I have another set of checklists, Inception Onward. And basically, Inception Onward, which is kind of what I've been talking about and what Travis talked about some, is where, yeah, magic. The forward movement of creating resources and state and having a point of view on those things, and those things and their point of view out into the system or into the world of systems, right? The resources are basically just like what you would, well, in Terraform, everything's a resource, right? It's either data or a resource, and data eventually becomes a resource anyway. And resources can be an instance in a cloud environment, or it can be a whole network, or whatever. There's a whole plethora of things that a resource can be. Basically anything that you need in a cloud environment, or even in some situations a physical environment. I even wrote some Terraform to deploy stuff to RFID readers that would then manage RFID chips throughout like a port. That was kind of rad. But you get the idea. Resources can be these virtual things, or they can even be physical things out there. It kind of maps to what other companies and other things are called in the context of resources. State is the same thing. You start with something, and then you want to change it to be this new state. Okay? And then the perspective is what do those systems see, and what do you see of those systems once you change that state? And I'll talk a little bit more about each of these three things in just a second. Oh, there it is. So like with Terraform, one of the things he was going to do, and you're going to see right here, this is actually creating an entire systemic environment. You'll see it's got some compute addresses that it's starting to build out. It's actually building out some networks. It's got CIDR ranges for the networks, blah, blah, blah. The whole thing that you need to deploy out like a development environment, a production environment, respectively, with nodes, et cetera. There's a Bastion server. There's actually a cluster that's being deployed out in this situation. All of this is going on with Terraform. And when it is done, you will have the immutable state of the described configuration, right? Great tool for that. Here's one of the things where you don't particularly have immutable state. You can do tricky stuff and breach the concept of immutable infrastructure. You can put bash scripts in there to run post-execution or pre-execution. And that gets even trickier and compounds the situation of, like we were talking about with the kind of built-in looping, some of the built-in pseudo structures that they have for Terraform itself. You can, I mean, with Bash is what the whole world is created on, right? I mean, it's everywhere, and everybody does everything with it. So Terraform can get super complex, super fast at, I mean, it's a Cartesian product of complexity, right? It's just nuts. So you have to be careful with that. If you're using bash scripts, minimal. Keep it as much in that immutable state to new state as you can possibly keep it in. One of the ways around that too is like with GCP, you have images, AWS, you have AMIs or AMIs or whatever you want to call them. Azure, you have, I don't know, are they just call them images, I guess, maybe still? And I love how each cloud provider likes to make up their names specifically for whatever, even though it's just like the same thing. But in each of those environments, one of the best things you can do when you're going from state to state with Terraform is bake your image as much as possible with all the things it needs, right? And this is the same concept with like in Kubernetes, if you're using Docker or Rocket or whatever it is, make sure you have an image that's mostly done and you don't have to run a bunch of post-execution stuff. Because if you do that, then you're adding layers to that onion, right, that container image. And then you launch it and you're like, why is my container image 42 gigs? I don't know. Why does it take 10 minutes to start? Well, that's probably because there's a bunch of post-execution stuff that shouldn't happen.
And you have to connect to it via SSH.
What?
Right?
Yeah, exactly.
You have to open up an SSH.
Right. So there's a lot of things. Bake your images, container images, virtual machine images, whatever they are, or probably even the new micro images, whatever it is AWS just released. They called it micro VMs, I think is what they were calling it. Which I saw somebody say, like, is it a micro VM? It's just a small VM? Yeah. Yeah. I mean, microservices got dubbed. I was like, isn't that just web services that are smallish per domain? Weren't we doing that? Weren't we supposed to be doing that? I don't know. The industry does tend to chase its tail sometimes, but you know, you see how happy dogs are when they do that. So we're happy too. We're building stuff, you know. So the Inception onward checklist though is whatever I'm using, whether it's Terraform, whether it's Ansible, whether it's Chef or Puppet, one of those tools. These are kind of my checklist for that tool. Can it do immutable? Can it deploy out immutable infrastructure? Is it going to perpetuate, encourage, or get people to build things and then mutate it a bunch, i.e. run 8,000 bash scripts post facto of deployment, right? Or is it going to let you trick yourself like with Terraform and, oh yeah, check it out, I deployed a 4,000 node Cassandra cluster. Oh wait, I'm trying to run Terraform apply again and it's trying to recreate a 4,000 node Cassandra cluster. Ah! I mean, you probably get fired if you did that. But you know, those are the types of things that you really have to be careful of, but you have to, you know, you want to, I always say, keep your infrastructure as immutable as possible. Sure, some things are going to come up because things do change once you deploy it. But your core bits, your core pieces, you want them to stay put. Like you deploy a network out there, you want the network to be there. You don't want it to tweak or mutate or freak out every 10 minutes. So that's one thing. Stateful. In the sense of Kubernetes, Kubernetes is freaking awesome. I love Kubernetes. But one of the things that it has hoped for, but like some of the previous past platforms didn't do so well, I remember I was working on Cloud Foundry 5,223 years ago, and it was really weird. They said, can you get React to run on Cloud Foundry as a data source? And I'm like, yeah, cool. Why wouldn't you be able to do that? It's just a distributed database. I didn't think too hard, obviously, because then I worked on it. Whew. Cloud Foundry initially, can't speak for it today, and now it uses Kubernetes and does whatever it wants to. But initially in the early days, basically the concept was in Cloud Foundry, you're deploying basically an application, a vertical application, traditionally built like, what was it, J2EE? Yeah, or ASP.NET. Right, yeah, sorry, I was trying to be gentle when I said those. But yeah, like those, it's a vertically sliced app. It's like, oh, it's tightly coupled to the database half the time, right? And you have a database in something that's just one database with one node, usually like Oracle or SQL Server or maybe MySQL, who knows, with no relational integrity in it. And then you have your app, maybe middle tier, right? But it's a very vertical slice. Cloud Foundry was focused on making it super easy to deploy that, right? Whether it's Node.js, Java, whatever. So all of a sudden, I'm trying to get React deployed out there, and I'm like, oh, well, I got a node deployed. I did that first easy step thing, right? I was like, install thingy. I have it out there, and I'm like, okay, so now I can get Cloud Foundry to bind that in the app. But then I'm like, wait, Cloud Foundry has no concept whatsoever of a multi-node distributed system within Cloud Foundry itself, right? Immediately became a problem. I don't know if that ever got resolved. But what has resolved it is like stateful sets, Kubernetes, the promise of operators, et cetera. Having the distributed system understand the distributed systems within it make it possible for something like Kubernetes to actually have those systems out there, to set up and deploy a change that then won't be destructive like Cloud Foundry used to. If you deployed that one node and then the distributed system worked like it was supposed to and that node went down or something, what would recover? Nothing would recover. It wasn't a thing. They even advertised that they could do a distributed system, and like at that point, it was not really a thing. But now with Kubernetes, that's becoming a possibility on container tech, which is a good thing. Let's see here. One of the little demos I wanted to do here. Boom. I was going to deploy a Pulumi app. No, I'm kidding. So here's this. Nope. Hold on. Computers. Open display preferences. Mirror computer. I think I did the dark theme on Mac now, and like the mirror button is not where I don't know. Maybe it's just me. I blame myself for now. So yeah, now you can see it. Yeah. Everybody see the text okay? I hope so, because that's huge now. Basic.tf files. This is basically the thing that I showed in the video earlier in the slide deck where it deployed out the entire environment. And I have it where the creator.sh, the bash script, okay, I have it set up where I use this very immutably, but it's tricky, and I'll show you. This is, however, a great way to set up an environment and then basically hide this creator.sh script. Now, mine is pretty simple because I wanted it to be, I didn't want it to have like 5,000 lines and not be representative of what I'm trying to do. So you'll see right here I start state right here. This is its own little Terraform project, right? It has its own little connection, and then it has a state resource. So the state resource is just a Google bucket, multi-regional Google bucket. And And I enabled versioning, because that helps when you're trying to debug your state. And the only purpose of that, and the only time it should run is once, on the inception of my environment being created, right? And here's my connection with my secrets. If you're wondering, this file is an interpolation. It looks at the account.json file, which is not in my repo. It's outside in my secrets directory. So I do that, keeps all my secrets outside of it. Nice little way to do it. And I just put it in West 1. West 1 is our local data center down in the Dalles. I always like to point that out because, yeah, local Cascadian bioregion data center. Probably completely destroying the environment, but anyway. So that creates the state. And in my creator.sh bash shell here script, I basically give the bucket a name. And then this first part up here, where it just looks in the state directory and runs that, it inits, which goes out and grabs the providers it needs to work with Google. Okay, that's all it does for that. And then once it does that, it goes back out to the root, where it starts to build out the current state that I want for my whole systemic environment. So what I've done, and why I only run this once, is once this runs, I have my initial starting state, and I have something that's managing my state. So now other Terraform developers, IT people, DevOps people, whatever the title is, I don't know. But people that need to work with this can now all work with it out of basically a Git repo, right? Or you can use SourceSafe if you want to, or nah, just use Git. It's cool. So let's run that real quick. I say real quick, it'll take 10 minutes. There we go. Bloop. So that's running, and you saw that in the video earlier, so it's going to work on that for me right now. See here where it says computed? This is where that looping, if you put count in the resource, will mess you up with a distributed system. And that's why in this particular situation, I am getting my addresses, I'm statically creating them so that I have a public and private one. The public one will be an address that Google just gives to me, whatever it is, some public address that can be reachable via the internet. Not that I'm opening it up at the exact moment, this exact moment. And then the internal one is, the internal one is one that it gives me, and then the external one is something that I can designate, okay? Or I just mixed it up again. Anyway, the resources are in there declared that way. But the point is, with a public and private address, you can give it to that resource that you need to be static, so when it creates each of those nodes, at least the initial 3, it will create it and will not attempt to recreate it every single time that you run Terraform apply, when you do need to change from one state to a new state.
What's that look like in your code in the Terraform?
Secret. It's closed source. No, let's see here. Let's see here in the node. So really, I mean, the static is like I literally statically declare. Here's the Google Compute address, right? And Google Compute address. So I have 2. One's internal and one's public. So yeah, the public one is the one it gives me because it has to look at its range that it has, right? And then it'll assign one to it. And internally, I can use one of the internal subnet ranges, right? So here I just increment 10.1.0.5.6.7 for each of the nodes. So they just keep that address. That benefits me in 2 ways. I get a core starting distributed system. Okay, I have 3 nodes. Terraform won't try to change that every time now, unless I specifically go in here and physically change some characteristic that will require it to destroy it and create a new one. So like if I go in and change, say, machine type, it's got to destroy that and give me a new one with the new machine type. What I can do, though, which is super rad, I can start with these 3 nodes, and then I could create a module, or let's not go there yet. I could do these 3 nodes, and then I could say, here's a resource for what I want additional nodes to look like. Okay? Then I create the map, set a count, and I iterate through and get a whole bunch of dynamic ones that then I can point back to and say, like, you need to go and join the cluster that's, here's the IPs, right? I can point right at it because I know what it is. So that's one way you can use the static part, but then add as many as you need to as things change. So you can kind of auto-scale with Terraform, like if you wanted to put it into programmatic iteration, right? Here's where things get tricky. See, I have an install c.sh, blah, blah, blah. You can get into trouble there. But all my install actually does is just install Cassandra. Yeah?
So if one of your nodes, you have the private IPs there,
Mm-hmm.
one of the nodes dies, will Terraform spin that node with that private IP and observe it?
Terraform goes from state to state, right? So if something happens in between, it doesn't particularly know that something occurred. So if a node goes down, in the particular case of Cassandra, I want Cassandra to deal with that, right? I want it to manage it. Now, of course, I'm going to get to this in just a second too, as I slowly wrap up here. You want to have instrumentation. You want to have observability into what's happening, right? You want to be able to know when a node goes down, so that, yeah, Cassandra might be handling putting the data back out to different nodes or whatnot to manage that that's down, but you still want to know that this has occurred. You want to understand if events are getting lost and all those things. So that's autonomous of this, right? So using a focused immutable infrastructure approach with Terraform or whatever tool you're using kind of keeps the separation of concerns forced, right? Like Cassandra manages its nodes in its database, right? You, as the manager of the systemic environment, has various observable events, metrics, other things that you look at to manage that, right? So you take tertiary actions or you set up systems to take tertiary actions.
So is it reasonable that you would have another script that would dynamically create a node if you needed to make it sort of recover? I know ideally you would find what the problem is and you would kind of prevent it, but
Not in Terraform.
okay.
Unless you were trying to do some wild automation stuff with Terraform specifically in a weird dynamic kind of way. But what I would suggest is using the advantage of the built-in elements of the system, the distributed system specifically, to extend that, right? Because Terraform should have no insight into what Zookeeper actually is, or Cassandra, or React, or whatever, right? But like Cassandra, for instance, there's various things out there. Like you could use the DataStax Enterprise solution has all types of ways to look at and see what's actually happening with the actual cluster and set it up to say, because it's more than just the nodes. And you can say, well, if something disappears, you want it to attempt to recreate that or grab another resource. If a resource is available, that is. You might want to limit its resources. So there's systems in place that would do that for you. Or you'd want to build something like, say, Spark jobs to look at things like that if you're building a systemic environment. But again, the core principle there is kind of trying to keep a separation of the concerns to the tool to do a specific job. And also HashiCorp has some stuff too. You can look at Nomad. Well, like Vault is their security secrets thing. Nomad is their scheduler. And there's some other things. I'm spacing on what it is right now. Yeah, exactly. Something like that. So there's other tools that specifically handle like, well, what happens if this particular thing, like a node disappears? Does it know about its resources or not? Like, how do we get it to manage itself at that point? All right, so let's hear. That should be. Oh yeah, it's done. It just didn't run the bash scripts. See, there's that mutability problem causing issues. But the resources are there. So if I go out to Google and, oh, wrong account. Sometimes I feel like I need a Terraform implementation to manage me and my 900 billion different accounts for everything. Is this? No, I don't want that one. Come on, faster. There we go. Anyway, if we go out, you can see the... Well, there's more clicks to this than I remember. Here we go. Okay, so this is the dashboard. But if you go out to the compute engine, for instance, you can see, there it is, my 3 nodes and my Bastion server, right? And I also created way more than that. As you saw those things go by, I created some networks, wherever the networks are. VPC network. Oh! Yeah, I keep forgetting. Who uses GCP? Anybody? Did you notice it used to be networks, and then it became VPC networks? I like that because everybody knows what a VPC is because of AWS. Meanwhile, there's another cloud provider that calls it like virtual network. I'm like, is that different? Do I need to learn something different? Or is it like, what's the context shift? Stop renaming stuff. When it's the same thing. Like if it's legitimately different, okay. But it's a network. So anyway, here's my DevNet. I had a DevNet right here. And I just put an east one and a west one. I don't like to make my stuff too complicated. And I always leave the default stuff in there. But basically, that's what all that did, and it gave me that initial state. So now, if I go in and let's say, I don't know, what do I want to do? Oh, let's say I don't like this node anymore, which is, node to address. Wow, that's a really boring name. Let's say that this is Frank node. I don't like Frank node anymore, so I'm going to get rid of Frank. So I've commented out Frank. And now if I go over here and run Terraform plan, it goes through and looks at the existing state that I just built and says, all right, I found some changes based on what you just told me in your configuration that you want with what I know to be the existing state, which is in that little bucket, that Google bucket that I started with that initial Terraform project. And what I know, Terraform that is, this is Terraform speaking, it has 2 things to add, 5 to destroy. I just deleted one thing. Oh, no, I didn't. There was a whole bunch of stuff in there. There was the public-private IP, there was the actual resource itself, and then there's the various network elements that were attached to it. So that's why it needs to destroy 5 things, but it needs to add 2 things because basically it's going to destroy 2 and probably recreate those 2 things that appear to be changed because the other thing needs to change. Because what it does is it creates the whole graph, right, of changes, looks through that, and determines what it needs to do. And then you just Terraform, apply, and it goes through, does it again, and you say yes. So that's Terraform. That's a great way to manage your environment. But it is, what? Did it do something? Oh, it's doing all of them? See, it's tricky.
You didn't read your plan.
Yeah, exactly. I didn't read my plan. The good thing this is only production. Yeah, as I do this, people in engineering are like, dude, do not give Adron production control of anything, please. He just wiped out all that stuff. But yeah, so fun with Terraform. It's a great tool, but like anything with distributed systems, it's tricky. You really got to watch out. It's not like just deploying an app server and going, okay, I got the box, it put some stuff on it, now I'm ready to go. That's great if you use it there. That doesn't have a lot of implied complexity to it. But the minute you start using these tools with distributed systems, you got to think about the fact that you want to go from point of state to point of state, and in between that, the distributed system is going to do all sorts of whatever it is it's going to do to itself. All right. Oh, look, there's a little dot came up. What did that do? No. Somebody hacked my terminal. All right. So the last little bits here. So in the sense of systemic coverage, when you're building out a distributed system, the questions you brought up, key things here. You want to be able to monitor, maybe, right? You want insight into it somehow. And you want to be able to make observations about it. And that is from way high up at the executive level all the way down to individual contributor level. Sorry, I'm redoing it so I can look at all my notes so I remember to say everything. There we go. Now, you do want, in this situation, to very distinctively be able to have insight about what you want. You want to be able to monitor it in a distributed systems environment. There are some trains of thought that will say, no, monitoring isn't that big a deal. You need just observability or something like that or whatever. But when you're looking at a systemic environment, you want all the data available to you. You want all of the choices that you can have to you all the time, because you need to be able to make decisions based on all of that stuff, right? Because you need to be able to prove that the distributed system is working, that the applications are running against it, et cetera. And you do want to be able to observe not just the systemic environment, but the specific events occurring from the applications, right? I mean, why else would you have a systemic environment? I mean, sure, some people just want to run servers and stuff. That's cool. Nothing wrong with that. But at the end of the day, a business is trying to do something, or an organization is trying to do something, and they want the apps and they want the services to work. And the best way to know that your apps and services are working is through pretty intense observability, which involves instrumenting your apps and really digging in. Like, you need to know when the events are firing. Like, sure, the CPU load is up. The RAM is spiking. Are the events firing or are they not? These are disparate things, right? Maybe the resources are spec'd out like crazy and everything's working fine. You need to be able to research these things independently of each other and trace into that. If things are just sitting there idle on CPU and memory, but all of a sudden your events aren't firing in the occurrences in the path that you need them to, you need to be able to trace into that. So that's where monitoring comes in from one perspective, and observability of the actual systems, the individual pieces, the individual resources, comes in at another level, and you need both to really be able to have insight and prove out that a system is in a particular state or not. Were you going to say something? You got a question?
I was wondering, from what you said, I don't really make, what's the difference between observability and monitoring, but maybe that's the next step.
Well, yes. So, monitoring generally, when we get into the pedantic notion of what one of these things is or not or whatever, so observability, in a very rudimentary sense, is more application focused or services focused, right? Like within microservices. You need very high cardinality data to be able to trace specifically into things to look at what is actually occurring, right? And that's where you need to get in and you need to instrument the applications. Look at your methods. When it fires, it needs to tell your observation system, your observability system or whatnot, it needs to put that data somewhere so that you can look through that data very quickly, slice it, and then get into the problem, right? This is almost like a debugging tool, more than it is really a monitoring tool. But you jump over here to monitoring, and what it generally, like when I'm saying monitoring in this context, we're talking about liveness. Can you ping it from somewhere? You know, like, can you ping it internally? Can you ping it externally? Can you get it from East Coast, West Coast, Eurasia, whatever? And then also metrics of the operating system, like how many threads are running? What else is running on the machine? Have I installed Wireshark? Has it sucked up all the memory, and is it crashing my node every 5 minutes? You know, you want to know those types of things. That's peripheral to your application, right? Like your service or your microservice isn't going to go, hey, Wireshark's running and eating up all the memory. That's not what you get out of that. It's complete breach of separation of concerns. So, and then the metrics of the apps, very general sense, like you look at the thread of the app running or the thread of the service on the machine or the container or the whatever. And then app services, kind of the same thing in this context. But it's those higher resource level metrics that you're looking at versus inside the services and the apps themselves. And then in the context of tracing and distributed tracing, open tracing, phooey, I hate it when I forget the name of something, but Zipkin, I think, is what one of the solutions is out there. Cool, I see heads nodding, so I said it right. So Zipkin is a super awesome one. I've used it before. I've looked at honeycombs too. If you have distributed systems, get this, because holy moly, it's super awesome. Like, it actually gives you context of what's going on systemically, not just from individual high cardinality point. That's great, but you might only trace into one node. Like, one little thing is happening on a node, but this will give you more insight into what's happening all around and what's happening from node to node to node, et cetera. And as you add instrumentation, that level of tracing becomes infinitely more useful. And then, I forget exactly what we're saying, but we're talking something about the context of, like, how do you manage those things once you get it out there into a state, right? You add or remove resources, and that goes from state to new state. But in between there, let's say something goes down. That's where you need effective reporting, job runners, or schedulers, et cetera, to be able to recreate resources or even decide to recreate resources. Like, should it wait 5 minutes? Should it do something? Like, in the context of the future wonderful world of operators and Kubernetes. Like, let's say let's say something decides that a node needs to go away in Apache Cassandra for maintenance, okay? Well, it'd be nice if Kubernetes knew that was going to happen, because otherwise, Kubernetes' default response is like, oh, a pod just got yanked out for some reason, or this resource is gone. I'll put it back. That's awesome. That's what Kubernetes is supposed to do. But in this particular context, you want that to go away. You want it to drain the data, and then you want whatever to happen, right? Like, let's say you're gonna recreate you're gonna destroy that node and then recreate a new one that's patched or something, right? Like, that gets rid of the cryptocurrency bug. Who knows? When you put it back, you want to be able to re-add it, let the data replicate back out appropriately, and then take down the next node or something, and then just go around it for, like, a maintenance reason. Right now, Kubernetes generally doesn't always know that. If, like, a distributed system might be used that way, but Kubernetes wouldn't particularly know that. But in the future, it would, and it would say, oh, I have logic around this. I need to wait 10 minutes before I arbitrarily decide to put a resource back out there for that thing. And by then, usually, you can do your patch or whatever and then pop it back in there. So that is 99% of my presentation. The general gist is create these checklists around your infrastructure at the various levels. Think of it from time-based, going forward, and then think of it systemically. And map it from that point of view. Create your checklist to map out from those two angles, and you'll have a much better handle on what the particular environment is being used for, what it's doing, and whether you're getting good performance out of it or not. Trying to fight with them, and I know some environments you're kind of stuck with this, where some of it might be immutable, some of it might be mutable. You might have some Chef and some Terraform, and you might have Apache Cassandra, and you might have HBase, you might have Zookeeper. You might have all of the things, and the practices for managing those might differ and conflict with each other from the IT perspective. But to really get that under control, there needs to be agreement to move forward in the context of, like, in my opinion, use an immutable infrastructure concept as the baseline and move forward from that perspective. Keep a view of the systemic environment. Don't let stuff start to be managed in some wonderfully bespoke, artisanal, handcrafted way. That's nice, but, you only want to buy one $6,000 suit in your life. I guess maybe some, if you have more, if that's pocket change, whatever. But you get the premise. Like, you don't want to just go out and, like, every server becomes your best friend, because eventually it's going to get nuked, right? So that's my 2 cents on the whole matter. create checklists, think outwards and systemically. Questions and thoughts? Anything? Yeah.
So it seems like you're thinking about persistent store nodes like Cassandra and Zookeeper, is that you should treat them in Terraform's terms more like pets than livestock.
At the starting point, in some ways you have to do that, or
Terraform, yeah.
they will be destroyed every single time. So like, well, I'll just throw in and add this context. So like that little 3-node cluster is really just like one, right? Even though you have to name them uniquely and make sure that they're static, because you don't want that to be recreated every time, because it would destroy the whole cluster, wipe out your system, and in the meantime your apps are flaking out or whatever, because you can't recreate it every time. You need that data to stay. It needs to be not static, but it needs to be stored and recoverable, and new data needs to be added, et cetera. I mean, it's a database, right? So you don't want that to get messed with.
Yeah, and that's fine with me, and I can
Yeah.
certainly see where you could basically name things like Zookeeper 1, Zookeeper 2, Zookeeper
Yeah.
3. Okay. I'm anticipating, though, that maybe you have a fix for this. Even if you're using modules and you're trying to maximize reuse, you have these, say, 5 or however many different nodes, each separately defined. Typically, I would imagine that 80% of the configuration is going to be the same across all of them. Is there any way
Right.
you can reuse that?
So modules work in some ways, but you also have to watch. So modules will determine certain things are dynamic, and even if you've statically said, like, here's my 5 variables, pass this into the module and create the resource. Well, those 5 variables, if they're for one of the key things, like let's say the ID, let's say you're passing that in, it's statically passed in as you've given it the value, right, for that variable. But when it's in the module's like, I don't know if this is different every time, so I'm going to assume it's different, and it'll recreate the resource if it's a module. So that's why I had to basically create the first 3 nodes as static resources in their place. One of the things that you can use, there's other tricks and ways to deal with this, though. Like, you can set up data and you can set up the mappings to be statically assigned to initial resources, right? So they're created, and then Terraform knows that they're not actually changing, and it'll leave them alone. And then you can just do the additive parts. So it's mostly, you have to be aware of what Terraform is actually going to do, what it thinks it's going to do.
Let's just say that I have a resource, you do the module.
Right.
The module for a Cassandra node specifies maybe 15 different things. And across all 5 Cassandra module specifications, 11 of those things are always going to be the same.
Right.
How can I avoid repeating that 5 different times?
Well, and that's where you use a module.
Well, no, I'm
But
saying,
you have to
the configuration of the module is going to be repeated 5 times.
configure. So you just
So you're
pass in the
passing
configuration, right?
variables- Oh, so you're passing variables into the module. Well,
Yeah.
okay, then maybe it's common variables in the module itself.
Mhm.
Okay,
Yeah.
yeah. I get it now.
Okay.
Yeah.
Cool.
One thing I thought is that you kind of have to like test it and see what
Yeah, you definitely need.
ends up coming out on the end of the plan.
Yeah.
Because I've been surprised. Sometimes
You definitely need to be able to test it. Because even like AWS to GCP to Azure, the behavior is going to be slightly different. I mean, we got different people writing these providers, right? It's not like a central group committee that's going, this is exactly how behavior needs to occur on clouds, make it work this way. And then, of course, they're writing the providers, but then underneath, like the Azure teams are doing one thing, the AWS teams are doing a different thing, GCP teams are doing a different thing. So the respective environments also underneath all of that work differently. So there's a lot of dynamic thought that's occurring that makes you really have to test out in each one. So even if you're going multi-cloud with Terraform, say you deploy out your 3 data centers, you go, and I've done this where we have DataStax Enterprise Cassandra deployed out there, and we have Azure with 3 nodes, we have AWS with 3 nodes, and GCP with 3 nodes, okay? And the tricky thing is once it's out there, I just let the DataStax Enterprise stuff manage that. Because Terraform can give me that initial state, put all that stuff there, and then that's basically the end of its life. Like the Terraform doesn't need to do anything else. Like I can scale up, scale down, add resources or whatever through the management suite of that. So
And I think the answer to my question too is that those variables that really don't vary across nodes, they can be placed in the module itself, or the
Yeah.
defaults in the module.
but test it though,
Yeah.
because sometimes Terraform thinks like, oh, this is just random dynamic stuff and I need to recreate it all. So it'll destroy a bunch of stuff and then you're going, oh crud, it just wiped out my whole database. So, so cool, ... ellipses. Let's continue the conversation, but I'm gonna say a few more things real quick. If you're curious about Go coding, especially site reliability, CLI type stuff, I'm gonna be Twitch streaming / YouTube streaming, building out a whole Go app this 29th and 30th, which I think is Thursday, Friday. So it's pretty cool. I'm gonna use the Twitter API, pull that stuff out, and I'm gonna end up dumping it in various export formats like JSON, XML, etc., but also out into an Apache Cassandra cluster, just for fun. So if you're curious about Go coding, I'll be doing some of that. I also write a blog about all sorts of topics. There it is. And this slide deck I will make available on the Meetup website in the resource list thingy, whatever they call it on Meetup. I don't know. They keep changing the name of stuff on there. So that the slide deck will be there. Those videos that I do for that and the videos for this, those will all be available or linked via the Meetup site and also out at DataStax Academy. So this talk and Travis's, unbeknownst to him, will be available there. Actually, he knows. He knows now. Yeah, his repo will be out there. I've got a couple of repos too, including that Terraform one, which you can go check out. Freebie, it's open source. I'm not cryptocurrency mining or anything or stealing, but it doesn't really do much. It just builds a few things, but it's a great example to get started with some of the concepts that I've talked about, especially like creating a checklist and going like, all right, so I built out a systemic environment. Now what are my next steps? And there's all my info. If you want this stuff, it'll be on the link on Meetup. So, and I think everybody knows I have a Twitter account, right? Thank you.